Hi, my name's Stuart Lynch and this is the third video in the Xcode SwiftUI workshop, and in this video we'll continue building our How Much application. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. You can continue on from where you left off in the last video using the same project, or you can download the completed project from the link in the description. There are 4 actions that we need to code to make our application functional. Each time we tap on one of the number buttons, we'll need to append it or add it to the end of our total string. However, it is currently set for 0, so we'll need to do a conditional check first, and if it is 0, we'll replace it with the number that was tapped. Otherwise, we'll add it to our total by appending the number to the end of our string. Functions, like other properties, get created outside of the struct's body view. If we collapse the body, we'll see that that is where we created our number button function in the first place. I tend to put all of my properties above the body, like these, and functions below. So above the number function, we'll create a new function that we can call addDigit, and it will receive a number as a string. Now note that by using an underscore as the beginning of our parameter label, it means that when we call the function, we can simply pass the string without specifying the argument name. For example, we'll just do add number 7 instead of saying add number 7. Unlike our number button function, this function will not return anything. It will only perform an action. So we can create that condition using an if-else clause. And to compare two things in Swift, we use a double equal sign. So if number equals the string 0, we replace that total with the number. Else, we can append those two strings together, namely the total string and the number string, and to do that, we just simply use a plus. Well, this can be simplified using what's called a ternary operator. And a ternary operator is often referred to as WTF, which stands for what, true, false. And you can evaluate and assign the result based on what condition, which must be either true or false, and then provide an option for the true and an option for the false. So we can comment out that code and replace it with what we are trying to evaluate, which is our new total. The what is our condition, which is comparing the number to the string 0 using double equals, and then this is followed by a question mark, and then the true option, which will be the number, then a colon, and then the false option, which is the current total plus the number. Now that we have that function, we can use it as the action for every one of our number buttons and pass in the number that is the label string of that button. If we test, we can see that it works. However, if we go beyond 6 digits, we're on to 2 lines, and that's not good. We can fix this by applying a line limit to our text view that displays the total, and then we can specify a line limit of 1. Well, this limits the line, but it also truncates the number as soon as it exceeds 6 characters. That's not good. So to accommodate this, we'll do what the iPhone calculator app does, and it reduces the text size. And we do that using a minimum scale factor modifier of our choosing. So I can apply that to our text view, and I'm going to specify 0.5. Now our bill will have to be awfully large before it starts to truncate. I suppose as a bonus, you could try and limit the number of characters entered. Right now, there are 2 issues with the decimal. I'm able to add more than 2 digits after the decimal, and I can also add a second decimal point, and this makes no sense whatsoever. So to handle this, I'm going to create 2 computed properties that will return a Boolean value, meaning either true or false, and then I can use that to determine whether or not I can add more digits or a decimal point. So as I said, we'll create our properties at the top. So I'll create that computed property called CanAddDecimal that will return a Boolean value. Well, this means we'll need to provide a check that will either be true or false. So what I want to do is to count the number of decimal points our total already has, and if the count is 0, I'll return true, meaning we can still add one. Otherwise, I'll return false, which is going to restrict me from adding one. We can use a filter function on a string because a string is a collection of characters. So if we filter and look only for the period, within quotes, we'll get a collection of only periods, and we can use the count method to provide us with the number of those periods within that collection of strings. Well, we'll start with the string total, and then apply the filter method. And inside here, there is a function closure, so we'll use braces to define our code, and then we can use $0 to represent each letter that the filter function will have to iterate through. And then if the condition is that we only want ones that are equal to the decimal point, using the double equals, those are the ones that are going to end up in the filter. So now that we have those filtered array of characters, I can count them using the count method. So if the period's count is equal to 0, remember, comparison requires 2 equals, we return true, else we'll return false. Using what we just learned about the ternary operator then, these 4 lines can be simplified into a single line that returns the truthfulness of comparing the count of the filter to 0. It'll either be true or false. And since there's only one line in the body of our computation, we can omit the word return. For a video on filtering and other higher order functions, I recommend that you watch this video. I'll leave a link again in the description. So we'll need a similar function for CanAddDigit. Again, we'll start with a computed variable called CanAddDigit that will return a Boolean value as well. So we'll need to be able to compute the index or placement of the decimal point and find out what that distance is from the start, and then subtract that from the total number of characters to see if we have more than 2 digits after it. So first we can use what's called a guard check to see if the decimal index even exists. A guard statement in a function must be evaluated as true before it can proceed to the next line. Otherwise, you provide an alternative that will exit the function or computation. So if we're successful, we can then calculate the distance that it is from the string total start index to the location that we just discovered. We then evaluate if the count of the characters, the totals.count, minus the index, minus another 1 to handle the actual decimal, and check if it is less than 2. If it is, we'll be returning true. Otherwise, we'll return false. Now, this is some pretty heavy stuff, and how did I figure that out? Well, I Googled it. If I had that question, it's likely that someone else did. So if you carefully craft your question, you are likely able to find an answer. But just be sure that you understand the code that's going on. With these 2 properties now available, I can make some changes to my addDigit function. First, we'll check to see if we can actually add a digit, because if there's already a decimal place and there are 2 digits after the decimal, we aren't going to be able to. Then we check to see if we have tapped a decimal place, and if so, we'll see if we're allowed to add it. Then we can use an old JavaScript typescript here that is to shorten the code to simply total plus equals number. And this will combine the equals and add the right-hand side to the left-hand side. So if it's not a decimal, then we use what we already had in place. And remember our keyboard shortcut for moving lines up one line at a time? The Option Command left square bracket? So far, so good. We still have to code the action for the backspace button. For this, we'll check first to see how many digits we already have in our total by using the count. If it's equal to only one digit, when we backspace, we had better set that string back to a 0. Otherwise, we'll simply remove the last digit using the strings remove last method. For the clear button, it's very simple. All we have to do is set the entire total string back to 0, and we'll leave the num people and tip % the same. The calculate button isn't actually going to do any calculations. Instead, it's going to present a second view that will handle the calculation and display them to the user. The presentation of that view is going to be done by way of a modal sheet that pops up partway from the bottom of the screen, and we'll prepare that in the next video. But in order to do that, though, the calculate button is going to have to toggle the action by simply setting a state variable to true. So this means that we'll need to create another state property on our view that will be initialized first as false. And then when someone taps on the button, we can set it to true, and that's going to trigger the presentation of our sheet. Well, there's one more thing. If our total is 0, then there's nothing to clear or calculate. So what I want to do is disable both of those buttons, if that's the case. So we can apply a Boolean modifier to the entire H stack containing both of those buttons, and then it'll get applied to those buttons, whether it be true or false. The argument for the disabled modifier is a Boolean, and it'll be true whenever total is equal to 0. And since total is a string, we'll have to compare it to the string 0. Well, this is looking pretty good. But what if I start with a decimal? Our buttons are enabled right away. So we'll need to fix our comparison. And we can do that by converting the total string to a number using the double function. And then we can compare it to the actual number 0. So 0 decimal is going to be evaluated as a 0 as well. That's better. So in the last video for this application, we'll build out our totals view that will get presented when we tap on that calculate button. And then we'll add some image assets to give our application an icon and place an image on the total screen when it pops up.